Welcome back, Grade 6, to Nelson Math, Chapter 8, Section 4, Area Rule for Triangles. A couple of things that I would like to share with you before we start is a quick review of how we measure triangles. Whenever we measure a triangle, we always measure the base, which is this part right here, and that would be the part that touches a horizontal line. So this is our base. The base can be anywhere, but we must be consistent with what we choose. So right here, this is our base, this entire length right there. The height, on the other hand, as our parallelogram from the previous unit, the height is never on a slant. The height is always the perpendicular measure from the bottom all the way to the top. It's never from one vertex to the other vertex, unless the triangle happens to have that side of the triangle which is already perpendicular, like a right triangle. I can show you one of those triangles. This triangle here, for example, the height would be from here all the way to the top. But this line is not slanted. It's at a 90-degree angle. This one is slanted, so we never measure that one in terms of height. Height is always from the lowest point to its highest point in a straight line that goes directly up and down like this. An example that is not the height would be from this vertex to this vertex. The height, if we want to measure from this vertex, would go all the way up to here. So we take the height from here and take that. So we don't need that one right now. So this is our base, and this is our height. So let's see what happens if I take two of these and I put them both together. If I take two of them, you see I have two triangles here. I have one triangle, which is one from the previous page, and I took another one, which is exactly the same, and I put it right beside. Here we have, if I move this out of the way for a moment, here I have my triangle dimensions. It would be a height of 8 centimeters and a base of 5 centimeters. So a base of 5, which is labeled right here, and a height of 8, which is labeled right here. It goes from here all the way to the top. So I copied this triangle, and I put it right there. So it's an exact copy. If I now find the area of this parallelogram, we could use our previous information. So the area of the parallelogram would be 5 centimeters times 8 centimeters. So this whole thing is 40 centimeters squared, or 5 times 8. But because I copied this exactly and put it over here, this area of the parallelogram is exactly twice as big. What if I removed half of it? That means the area of this triangle is exactly half the area of the parallelogram. And I've written that right here. The area of the triangle is half the area of the parallelogram. So if the parallelogram is 40 centimeters squared, and our triangle is half of that, we could do 40 divided by 2, or 20 centimeters squared. So our area rule is base times height divided by 2. Another way of saying this exact same thing, which is completely equivalent, would be base times height divided by 2. You may see different formulas in other places. You may see half the base times the height. You may see base times half the height. They're all equivalent. The formulas are all correct, but you must apply them correctly. If in doubt, start off with your triangle. So let's take this one right here. I have a triangle that has a base of 5 and a height of 8 centimeters. But you might have forgotten what the formula for that is. Take another triangle, exactly the same, and you can see here, I just made a parallelogram, but my height is exactly the same as my old triangle, and my base is exactly the same as my old triangle. So now I can find the area of my parallelogram. because 5 times 8 is 40 centimeters squared. But if you don't want the parallelogram, you want just the triangle, you may do 40 divided by 2, which is 20 centimeters squared. Please draw them out if needed. That way you get more comfortable with being able to find the area of a triangle. Thanks, everyone. Have a good day.